Hello, Haystack Rock Awareness Program interpreters. This is Samantha Ferber, Haystack Rock Awareness Program Coordinator, here to talk about the Intertidal Exploration Station. Your station support sheets explain the activities and concepts discussed in this lecture, so don't worry about memorizing all this protocol and these objectives, but still listen closely so you are familiar with how these stations are ran. The purpose of this station is for the students to observe intertidal organisms in their natural habitat. These observations will be discussed after exploration to introduce key ecological concepts such as adaptation and zonation. The key to this station is to support student-guided exploration while introducing these key concepts based on organ science state standards. First, gather your group outside of the intertidal. Remember to wait for all students to arrive. Then, show them a barnacle or an anemone rock so they know what rocks not to step on. While you lead the group into the intertidal, introduce the station. Then let them explore. While they explore, listen to their observations. Try to introduce these key concepts as they make the observations, but remember to let the students guide your interpretation and answer the questions that arise. After they explore for about 8 to 10 minutes, have the students gather and share their observations. Try to relate these observations that they have made back to the concepts in the grade-specific objective. K through 5th grade introductions should be something like this. Today, you are explorers investigating the mysterious intertidal. How do all these sea creatures survive out of the water? Let's observe and explore to figure out how. The main focus of this grade group will be adaptation. Adaptations are structures, functions, or behaviors of organisms which enables them to survive and thrive in their environment. Intertidal animals need special adaptations to survive without water twice a day. Surviving in the intertidal requires staying wet, holding on, sensing surroundings, feeding, and breathing. Intertidal organisms have adaptations to do these things. In the pictures below, you can see that anemones close up tightly to hold in water. That's how they stay wet. Sea stars have tube feet that help them hold on to rocks during the low tide. Let's do a brainstorming activity. Take a couple minutes to make a list of the things you would observe about intertidal animals or algae at Haystack Rock. Think about how these observations represent an adaptation. Feel free to pause this video if you need more time. After the students explore, have them share their observations. Their observations most likely represent an adaptation. So define adaptation and try to connect those observations to the fact that this allows that animal to survive in the intertidal. A note about 3rd through 5th grade. This grade group will also be considering how organisms interact with each other, in addition to learning about adaptation. Can you think of some interactions you would observe between animals in the intertidal? Again, feel free to pause the video if you need more time. The focus of 6th through 8th grade groups will be interactions between organisms and populations and how changes in populations are related to resources. An introduction for this group should be something like, today you are marine biologists exploring how individuals and populations of intertidal organisms interact. Let's talk about some terminology here. Individuals of one species make up a population. Populations of species make up a community. Feel free to define these terms for your group before they explore or while they are exploring. Competition within and between species centers around limited resources such as space and food. Like every competition, there are winners and there are losers. The species that win will be more abundant. In other words, their populations will increase, while the species that lose will have smaller populations. Competition is when species compete for a particular resource that is in short supply. The resource could be space to grow or a shared food resource. An example of this interaction is a mussel and a barnacle competing for space. Another interaction you might observe in the intertidal is predation. Predation is an interaction in which one species, the predator, kills and eats another species, the prey. Sea star devouring a mussel is an example of this. Herbivory is another type of interaction in which an herbivore, like a chitin, eats part or whole of a plant or alga. The last interaction type is symbiosis. A symbiosis is a relationship between two organisms of different species that live closely together in direct contact. There are 3 different types of symbiosis: parasitism, mutualism, and commensalism. In parasitism, one animal is benefited while the other one is harmed. Mutualism is when both animals are benefited. Commensalism is a little more vague. One organism benefits while the other is not harmed or benefited. It's sometimes hard to tell between a commensalism and a mutualism. An example of this are zooxanthellae living in the tissues of an anemone. Have you ever wondered why a giant green anemone was so green? Well, it's the zooxanthellae that are actually doing photosynthesis to make sugars, or their food. This is an example of a mutualism because the algae gets nitrogenous waste and the anemone gets sugars from the photosynthesis. Let's do another brainstorming activity. Take some time to think about what kind of interspecific interactions you may see at Haystack Rock. An interspecific interaction is an interaction between individuals of two different species. What about an intraspecific interaction? This is an interaction between individuals of the same species. Again, feel free to pause the video if you need more time. Some examples of an interspecific interaction, or an interaction between individuals of the same species, an interaction between species that are from different species. Let me go back and start over. Unfortunately, I cannot pause this video and re-record what I had already said. So let me slow down to make this very clear. An example of an interspecific interaction, or an interaction between individuals of different species, is competition for space or food, predation, herbivory, and symbiosis. An example of an intraspecific interaction, or an interaction between individuals of the same species, is competition for space or food. Although two hermit crabs are from the same species, they're still competing for space to live and food to eat. And reproduction is another example of an intraspecific interaction. High school groups will be focusing on how the intertidal ecosystem changes in response to disturbances and interactions among populations. They will also analyze how the relationships among biotic, living, and abiotic, non-living factors determine zonation. An introduction for this group should be something like, today you're a marine biologist exploring the intertidal ecosystem. What controls the biodiversity of this ecosystem? Let's explore and observe to try to answer this question. Let's talk about these concepts. First, how the intertidal ecosystem changes in response to disturbances and interactions among populations. The graphic below illustrates how disturbances control populations in the intertidal. The x-axis illustrates increasing disturbances such as wave shock, sand inundation, or even trampling by humans. As these disturbances increase, it is more and more difficult to survive in the intertidal. Therefore, there are less species that exist, and the individuals that are in the populations of those species are lower, meaning there's less biodiversity. Biodiversity is illustrated on the y-axis. If there's too little disturbance in the ecosystem, space and food is limited. So species that often win competitions take all the food and space, excluding other species that are not as good at competing. A specific example of this is the mussel. If the ocean was calm, no mussels would be torn off rocks. The mussel population would explode. Mussels are one of the best space competitors. They will actually grow right over other organisms. With an intermediate level of disturbances, their populations are limited, allowing other species to exist. To sum this up, too much disturbance creates an unstable environment, and only the most resistant species survive. Therefore, the biodiversity is low. Too little disturbance allows competitive dominant species to exclude other species, again, making the biodiversity low. An intermediate level of disturbance allows a mixture of species to coexist in the intertidal. Interactions between organisms also control the populations of species in that environment. Predation, a type of interaction, has the same result as disturbance. Replace disturbance on the x-axis with predation. Too much predation will cause only the most resistant species to survive, leading to low biodiversity. Too much predation, only the competitive dominant species exist, excluding other species. An intermediate level of predation allows a mixture of species to coexist. Zonation is a product of these combined effects. Abiotic factors like disturbances and biotic factors like predation make species occupy discrete bands or zones in the intertidal. The different zones are, from top to bottom, the spray zone, the high tide zone, middle tide zone, and the low tide zone. What controls the organisms in these bands, again, is biotic factors and abiotic factors. How far up an animal can live in the intertidal is based on abiotic factors or physical stress, such as heat, desiccation, and ultraviolet radiation, as well as the many other disturbances in the environment. As the tide rises, it covers intertidal rocks from below, this meaning that higher locations are exposed to the air for a longer amount of time. Animals with shells can hold water in their bodies for longer, and therefore can live higher. Soft-bodied animals without shells have to live lower in the intertidal because they dry out faster. This is why we see only acorn barnacles and limpids in the spray zones, and we see a diversity of animals in the low intertidal, such as anemones, sea stars, nudibranchs, sea lettuce, etc. The existence of species in the lower intertidal is limited by species interactions, or biotic factors. Because more species are able to live in the lower intertidal, there is limited space for animals. Competition over space is constant. Like every competition, there are winners and there are losers. The species that win, such as the mussel, will be more abundant, while the species that lose will be limited. When one species wins a space competition, it will sometimes lose other competitions. This keeps those populations in check. Predators, like the sea star, help limit populations of animals, so those who often lose space competitions can still exist in the intertidal. The combination of species interactions from below and physical factors from above create distinct bands where certain species dominate. The middle zone is dominated by mussels, for example. Living higher, they will be exposed for too long. And in the lower intertidal, mussels will be eaten by sea star predators. If you have any questions about the concepts and materials presented in this lecture, please feel free to give me a call or email. I love to talk about these nerdy concepts, so do not worry if you have lots of questions for me. Thank you.